All right, so additional topic number 3 is on trig ratios. You guys might remember it from geometry as SOHCAHTOA. That's how it's usually taught. How many of you guys have heard SOHCAHTOA before? Okay. All right, so a trig ratio is a ratio of the lengths of two sides of a right triangle. So the word trigonometry is derived from the ancient Greek language, and it means the measurement of triangles. So measurement of triangles. So metry is measurement, trig, tri means try, 3 sides. Gon means sides, right? 3 gon, like polygon. All right, so let triangle ABC be a right triangle. So let's draw a right triangle. Here's angle A, B, C. All right, so if I want sine of A, we need to talk about across from A, we call this opposite. So if I cross the whole triangle and go to the side that's directly across from it, does it make sense? Hypotenuse is always across from the 90-degree angle, so this is hypotenuse. And then the one that's left, so it's not the hypotenuse, but it's right next to angle A. It's what's the other side that's creating that angle. We call that adjacent. So we have opposite, hypotenuse, and adjacent. So if I have sine of A, we remember SOHCAHTOA, so S-O-H. So sine equals opposite over hypotenuse. So opposite over hypotenuse. So it was the S-O-H. Cosine ends up being, what do you guys think? Yeah, AH, so adjacent over hypotenuse. It's always something over something else. And then tangent is opposite over adjacent. So just remember the word SOHCAHTOA. It stands for sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So that's the SOHCAHTOA. So as long as you can spell SOHCAHTOA, you will be fine. I remember when I was in 9th grade and I was in geometry, my student teacher came in and she was telling us this big elaborate story about this Native American princess who led lost mathematicians to the wilderness of confusion, and I was like, wow, that's really cool. she was like, the name was SOHCAHTOA, and I was so gullible, like I totally believed what she was telling me. So she just made this up. So SOHCAHTOA is the Native American princess who leads mathematicians through the wilderness of confusion. Elaborate. Okay, so number 1. So use a calculator to find the following to 4 decimal places. So you guys have sine, cosine, and tangent on your calculator. Now, your calculator, when you're in calculus, you're going to use something called radians a lot. We're not going to use radians right now. We're going to use degrees. So first you guys want to hit mode. Do you guys see mode? It's on the very top of your calculator. So you want to make sure that not radian is highlighted, but degree. So it's like the 3rd row. You want to go over to degree and hit enter. Okay, is it highlighted now? So now do second quit. Quit is right above mode, so second quit. All right, so always make sure that you are in degree mode when you have these little degree marks. Do you guys see how there's a degree mark right there? So make sure you're in degree mode. So we have sine of 56, so I'm going to hit sine. It looks like sin. It's read sine. 56, enter. You should get 0.8290. We're going to go to 4 decimal places each time. Now do cosine, 84, enter. 0.1045. Are you guys getting these numbers? Good. Tangent, 16, 0.2867. Okay, number 2, this is what the first part of your homework will be like. It will say find the 3 trig values for angle A. I think on your homework I use angle theta. Theta looks like an O with a little line there. It's okay if you see theta. Theta is just a letter. It's fine. It's not one of our letters, but it's a Greek letter. Okay, so here's angle A, because it's next to vertex A. So if I'm talking about, oh, it said C is equal to 15. Do you guys remember when I see lowercase c? It's across from angle C. So we're going to go across here, and we're going to have 15. All right, little a is across from angle A. So that's over here. So I'll write C and A so you guys remember. All right, can you find B? Yeah, it's a right triangle. So we have 12 squared plus B squared equals 15 squared. So I get 144 plus B squared equals 225. 225 minus 144 is 81. That's convenient. So B is 9. So you can solve for B. B is 9. Okay, so when it says the 3 trig values, that means you want to find sine, cosine, and tangent. Now we never just write sine, cosine, and tangent. They always have what we call an argument. So they always have like sine of something, cosine of something, kind of like logarithms. Remember, we never said log equals 5. Log of what? Right? Same with sine, cosine, and tangent. Okay, so I'm going to have sine of, it says for angle A. So I'm going to say sine of A, cosine of A, tangent of A. It's telling me what angle I'm taking the sine of. So sine of angle A, remember, is going to be opposite over hypotenuse. That's our SO part. So looking at angle A, which is right here, what's opposite? 12. Hypotenuse is 15. 12 over 15, they're both divisible by 3, so I would get 4/5. That's your answer. Cosine of A. Remember, cosine is adjacent over hypotenuse. That's the ka, SOHCAHTOA. Adjacent. So if I'm looking at angle A, which one's adjacent, 9 or 15? 9, because 15 is already named something. 15 is always hypotenuse, right? It's across from the 90-degree angle. So I have 9 over 15. They're both divisible by 3, so 3/5. And then tangent is opposite over adjacent. That's the TOA part. So if I'm looking at angle A, opposite, so go across, it's 12. Adjacent is the one that's not the hypotenuse, so it's 9. They're both divisible by 3, so 4/3. Okay, those are the 3 different values. Now, could I find sine, cosine, and tangent of angle B? Yeah, you can find it for any acute angle. You don't find it for the right angle, though. We never do that. Okay, so sine, cosine, and tangent, you could find that for B as well. You would use different values for B, because now opposite would be 9, adjacent would be 12. Okay, so might change that. All right, so number 3. So it says the angle of elevation from the base to the top of a playground slide is 55 degrees. So we have our slide, here's the little ladder. All right, so it's 55 degrees for our angle of elevation, so the angle going up. The slide takes up 10 feet of space horizontally along the ground. So this is 10 feet here. Estimate the height and the length of the slide. So I'm going to call them H and L for height and length. Okay, we want to use the values we're given. We want to use the 55 degrees and we want to use the 10. What's 10 related to the 55 degrees? Is it adjacent, hypotenuse, opposite? What is it? Adjacent. So we know this is the adjacent. Let's say I want to find H. What's H for the 55? Opposite, right? So we want to use opposite and adjacent. So am I using sine, cosine, or tangent? Tangent. I want to use the TOA one. So I'm going to say tangent of 55 degrees equals opposite over adjacent. So you can write yourself a note if you need to remember opposite over adjacent. Well, tangent of 55 degrees you can find on your calculator. So I'm going to do tan 55. So I get 1.428 equals h over 10. I usually just keep that number in my calculator, and then I multiply by 10. So I'm going to multiply the 10 over. So I get 14.2815. Okay, you could say like 14, so about 14.3 feet or something like that. That would be fine. If it's a real life thing, usually I'll just do like 1 decimal point or 2. All right, how do I find L? So L is hypotenuse. Now you could use the value that you just found, but we've rounded that value. I usually just use the values that I had originally. So I would still try to use that 55 and 10 if possible. Okay, so if I have 55 and 10, I'm using adjacent and I want hypotenuse. So what uses adjacent and hypotenuse? Cosine, right? So now I set up my second equation with cosine. So I'm going to say cosine of 55 degrees equals adjacent over hypotenuse. All right, cosine of 55, go ahead and find it. You get 0.5736 equals 10 over L. Now here's where it gets tricky because I can't just multiply my 10 over or divide my 10 over. Do you guys see that we can't do that? Yeah, so I would think of this as over 1 and think about what you would do with cross multiplication. So you'd have 0.5736 L equals 10. So what am I really dividing by? I'm dividing by that 0.5736. So now I would do 10 divided by, and I have that answer in my calculator still, so I'm going to do second answer. So that way it's nice and precise. So when I do that, I get L equals 17.4345. So I'm going to say about 17.4 feet. Okay, that's the length of the slide. Does this make sense? Do you guys remember this? Yeah. I did 10 divided by my answer. So I left my answer in my calculator. So 10 divided by 0.5736. Yeah, so it's tricky. If the number's not on the bottom, right, the L was on the bottom, that's when you have to do that cross multiplication thing. Okay, let's try a couple more. So you're measuring the height of a tower. You stand 154 feet from the base of the tower and measure the angle of elevation from a point on the ground to the top of the tower to be 38 degrees. Estimate the height of the tower. So here's our tower. You stand 154 feet out and you look at the top of the tower. You measure this angle to be 38 degrees. So there's little devices that will measure angles like that. Have you guys ever seen surveyors out? It looks like they have video cameras. They're not video cameras. It's like little things with mirrors and angles and things. They're measuring angles to get distances. All right, so estimate the height of the tower. So find H. So go ahead and try that one. So try to find H. All right, so you should notice that the 154 is adjacent and the other one's opposite. So if you want adjacent and opposite, you want tangent. So you want tangent of the angle, 38 degrees, equals opposite over adjacent. So we do tangent of 38. So we get 0.7813 equals H over 154. I keep that answer in my calculator and I'm going to multiply that 154 over. So you should get H equals 120.317, well, 80. 180. So about 120.3 feet. Did you guys get that answer? It's making sense? Okay, let's kind of skip forward. I want to look at the solving a right triangle. You can solve a right triangle. So solving a right triangle means you can find all 3 side lengths and all 3 angle measures if you know either 2 side lengths or 1 side length and 1 acute angle measure. So if you know 2 things like that, you should be able to solve the right triangle. Okay. The way we're going to do this is if we want to solve for an angle A, we use inverse sine. Did you guys do that in geometry? Do you guys remember inverse sine? So if I want to solve for A, I do inverse sine of the other side, x. So I always say, okay, if I have sine of A equals x and I want to get rid of a sine, I don't divide by sine. We don't divide by sine. We do inverse sine out front. Kind of like matrices, we did inverses. Okay, so same thing for these. A would be inverse cosine of y, and A would be inverse tangent of z. Make sure you're in degree mode if you want a degree measure, just like before. So if I want to solve for A, I'm going to do inverse sine of my 0.9205. So do you guys see where inverse sine is on your calculator? Yeah, so you do second, you hit the sine button, and it comes up with sine raised to the -1. That's inverse sine. We also call that arc sine. So if you guys hear someone say arc sine, same thing. 0.9205. So we get 66.9993. So this is round in the nearest tenth, so it'd be like 67.0 degrees. Okay, that's A. Now I'm kind of lazy, and I just write A equals, capital A I know is an angle. If you want to be very geometry-like, you would say measure of angle A. I don't mind. So if you leave off the measure of angle, we know capital letters are angles, lowercase letters are side lengths, right? All right, so you could find all of these different things. So when you come to something like this, so number 5, if you wanted to solve the right triangle, first you could find this other side length y by Pythagorean theorem. So you'd say 8 squared plus 8 squared plus y squared equals the hypotenuse squared, so 10 squared. So you get 64 plus y squared equals 100. So y squared equals 36. Take the square root, so you get y equals 6. It's never going to be plus or minus 6 in these problems. It's always going to be a positive length. So we have the first side length. I always try to use the things I was given originally. So I would use the 8 and 10. Use it with any acute angle. So let's say I'm using W. So if I'm talking about W, how is 10 and 8 related? So 10 is definitely the hypotenuse. What's 8? Opposite. So I want to use sine. So I'm going to say sine of W equals opposite over hypotenuse. So you can write yourself a note if you need to for your notes. So that's 0.8 is sine of W. So how do I solve for capital W? Inverse sine. So capital W is inverse sine of 0.8. So capital W is 53.130. So this is round to the nearest tenth, so 53.1 degrees. That's what W is. Now you don't have to go through all that to find Y. So if you have 53.1 here degrees, how do you find Y? Yeah, they have to add up to be 180. So you know you already have 90 degrees in there. So I just do y equals 90 minus 53.1. Because I know those W and Y have to add to be 90. So 90 minus 53.1 is 36.9 degrees. So you've now solved the triangle because you have all three sides. You have 8, 10, and 6 in all three angles. So 90, 53.1, 36.9. Okay, so that's all you do for solving the triangle. It's not bad. So you guys should be able to do all of that now.